Thank you.
Okay. We don't need that. Yes. Got a problem?
I think it's like
Okay. So we are talking today, we're still in 11.1. We've talked about measures of center. There are 3 measures of center. What are the 3 measures of center? Mean, median, and mode. Those are measures of center, mean, median, and mode. We talked about outliers. What's the definition of an outlier? How do you tell, Owen, how do you tell if something's an outlier?
It's way bigger or way smaller than the rest.
Very good. It's way bigger or way smaller than the rest. On Friday, we talked about if you have an outlier in there, how does it change your mean, median, and mode? We talked about that. And so today we're going to talk about variability. Okay? So variability is, it's hard to explain. Variability is basically how different something is. Okay, so there are 2 ways to measure variability. Well, here you go. I want to give you an example of variability. Let's do this. Let's see. How many of you are just going to both raise your hands because I don't want to take the time to go at everybody. But how many of you are 14? Okay. Front row, how many 14s? 11. 12. Okay. Okay. How many 13s? Anybody 13? 15?
Levi's not in this class.
1, 2, 3, 4, 5. I cannot count! 4, 5, 6, 7, 8. Thanks. I was not frustrated you, it frustrated me. I can't count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 1, 2, 3. Okay, 3 people. You're not any age. Okay? So if you're 14, stand up. Raina, what are you?
I'm 16.
Oh!
Yikes.
Right? Oh, stop it, you bunch of bombs. Back row, sit down. 4, 5, 6, 7, 8, 9, 10, 11, 12. Whoa! 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Good job, 14. You're doing it right the first time. 15. 15. Stand up if you're 15. Raise your hand if you're.
Oh, you know what? In case it's not in here.
Yeah,
Case it's in your bathroom.
I didn't count it.
Case is like
1, 2, 3, 4, 5, 6, 7.
A crutch can't have it.
What are you? Okay. Well, 1, 2, 3, 4, 5, 6, 7.
I think there's 2 That's just too big.
You also forgot Case.
I didn't count him. I don't count people. There's 23 people in this room. I don't even know. Okay.
That's
Case is like 8.
There's only 21.
Case is the
You have 2
outlier.
16s.
Who else is 16?
Sawyer.
Is
Is that still last one?
Wait,
Yeah,
let's
so
do
it's
Miss
what-
Barnard's page now.
No. Okay. I don't care right now. So somebody is just present but not present. Let me ask you this question. If variability is a measure of how different something is, what do you think the variability would be? Like it's small, right? You guys are all pretty close to the same age. Now, listen. If I had Miss Barnhart and myself in, we're just going to put some numbers here, pretend numbers, because we're not telling you how old we are. But because she's 25 and I'm 26, if we put our 25 and our 26 in there, what's going to happen to our variability? Is it going to be smaller or is it going to be bigger? It's gonna be bigger because there's more differences, right? 25 and 26. Elijah, you got a problem with that?
Yeah.
Okay. So, question. If this is our numbers, we've got 12 14s, I'm not writing them all down. Okay? And we end up with a couple 16s up here. What's the range?
I think you skipped 50.
2. I didn't want to write them all down. That's all I'm saying. A bunch of numbers in there. Right? Because there's 12 14s, there's 8 15s, and 2 16s. I'm just not writing them, Cameron. Because I don't want to. Okay? What's the range? Range is 2. Okay? Because maximum minus minimum. Okay? What happens if I put our 25 and our 26 in there? What happens to the range? Nope. If I put my 25 and my 26 on there, what's the range now? It's a lot bigger. What's the range? 12. Okay? So range is a measure of variability. If you have a small range, your numbers are close together. If you have a big range, your numbers are farther apart. Okay? So, or let's see, we also want to say, or it could be how far apart the numbers are. Okay, so let me ask you this question. If let's say this, let's say I gave a test, okay, would I want you guys' range of scores to have high variability or low variability? I would want them to be low variability because I would want to see that you're all doing about the same, right? Hopefully all in the A's, right? Everybody in the A's, that would make me happy. That would be a low variability. What about, nobody in here on the bowling team, right? Okay. If you're bowling and you have a whole bunch of all your games for bowling or golf, anybody on the golf team? Okay, if you're on the golf team, same thing. Do you want your scores through the whole year to have high variability or low variability? Because low variability means you're very consistent. You're golfing or you're bowling the same every time. If you're bowling and you're like, sometimes I get 50 and sometimes I get 250, they're going to be like, well, that's a problem, right? You want to be consistent. You want to be always getting about the same. Okay? 250 isn't an amazing bowling score. Oh, yes, I'm sure you do. Low variability with your 300. Okay, so 2 ways to measure variability. Okay, the first way is range, which we talked about a little bit on Friday. So one more time, range is the maximum number, the biggest number, minus the smallest number. Okay, super easy to do range. You don't need a calculator to do it, unless you're like, hey, I need help doing 26 minus 14. Okay, range is easy. It's how far apart those numbers are. There is a second way of measuring variability that requires your calculator. Okay, and it's something called standard deviation. So there's a big giant formula for standard deviation. We're not going to learn it because why? Our calculator will do this for us. So the standard deviation, range is maximum minus minimum. Standard deviation measures how close the data is to the mean or average. How standard deviation works the same. A big number means all your numbers are far away from the average. So listen, the average here would be probably somewhere in the 15s with a very small standard deviation because everybody's really close to 15. Okay? As soon as you put Miss Margaret and myself in there, it goes up. Okay, we'll do that example in a minute. So what I want to do is show you how to use your calculator to get the standard deviation. So it's actually steps that you've already done. Some of the steps you've already done. Okay, so the first thing you do is you go to stat. So I've already been into stat, right? This is where we put numbers in. And you're gonna go right in and you're gonna put numbers in. Okay, so you're gonna enter the numbers. So here's what I want you to do. I want you to do 12 14s. So 14, 12 times. 14, and then start counting them. 2, 3, 4. Just a second. 12 times. 12 14s. Here's a little clue for you. Do you see that the bottom of mine says L113? That means the number I'm sitting on is the 13th one. That means I have 12 in there. That's what we want. Okay, you're going to type in 8 15s. Okay. So by the time you're done, you should have L21 down there after you hit enter the last time. You need 8 15s.
How many 14s?
12. Bless you. Okay, and then you want 2 16s. That one's pretty easy. I know, we won't always do the ones that are quite this big. Okay, so we put our numbers in. Once you do that, you're gonna go back to stat. This time you're gonna go right one, so use your right arrow and you're gonna go to calc. Okay, last time, don't push any buttons yet. Last time, what one did we pick? We picked 4 when we were here before. What we want this time is number 1. Okay, so it says 1 variable statistics. That means we only put 1 number in. Now it's gonna ask you what list. We put ours in list 1 and then go down and hit calculate. Okay, you're gonna get a lot of gibberish here. So I'm gonna give you some hints here. This is actually really nice for you. There's a lot of information in here. Okay, so I got some people writing. Okay, so now here's just a little bit of information for you. If you that X with the line over it, that's actually the mean. Do you have to know how to do that? Nope, because you can add them up and divide by how many there are. That's fine. But that's what that is. Okay, this little squiggly E with the X, that is how much it all adds up to. So if you're like, hey, I put them all into my calculator, I don't want to have to add them up. That's the sum. That squiggly E is a sum. Look at this N right here. That tells you how many numbers there are. Okay, we put 22 numbers in our thing. If you don't have 22 there, you missed a number, which is fine. I don't really care right now. Okay, now go down a little further. Look at what this guy is. What's that say? MED. What's that probably equal to? Yeah, that's the median in there. Also, you have maximum and minimum, and you could find the range from that but it's pretty easy to do this range. Now, this funky little thing that looks like an upside down snail to me, this guy is standard deviation. Okay. So when we're talking about measures of variation, it's this guy that you really need to find. Okay, it's the snaily thing. So our standard deviation of the ages in our class is 0.66 is what it is when you round it. That's a very small standard deviation, which we would expect because everybody in this class is 14, 15, or 16. Okay, everybody that gave me their age. Now, I want you to go back in because I want to show you what happens when we add in some more things. It's on my desk. Okay, so go back to stat. This is not extra steps. We're just writing this down. Okay, go back to stat, go into edit, and I want you to go all the way down to the bottom of your list. Okay, so I lied. Miss Barnhart and I are not 25 and 26. We're 35 and 36. So type in your 35, type in your 36. I did? You guys aren't believing 35 and 36 either?
No.
Why, you bums?
I don't think you can be called that.
Yeah. God, let's be respectful. I thought you were 18.
Okay,
Too young.
I don't know.
Too young.
Are you younger than that?
Am I younger than
45.
by like 6 months?
Miss Barnhart, she's 40. Okay, now go back. Let's go back and see what happens when we add in a couple older people. Only mildly, slightly older. You bums. Okay, so go to stat again. Go to calc. What one are we picking this time? Number 1. And you just go down and calculate. Look at what happened to our standard deviation. What is it now? Yeah, 8.56. So because we added in some numbers that were way far away from everybody else, we increased the variability.
Yeah, I messed up.
Okay, we increase the variability. So what that tells us is when it's just you guys, your standard deviation is 0.66. Everybody's about the same. As soon as you add in some adults, some well-seasoned, mature people, the standard deviation goes way up because that's a big difference. That's a big difference from 15 and 16. Okay, so here's what I want you to do. Let's have you do I'm going to give you the numbers in order. That's very nice of me. Actually, no, I'm not. It's fine. Okay, there's 10 numbers. Make sure you get all 10 numbers. I would like you to find the standard deviation and the range. So that's the little snaily guy and the range.
You need to put in your calculator
Yep.
in order.
You do not. You do. That's a great question. You guys, you do not need to put it in order in your calculator. Your calculator will do all its own things. So just pop them in exactly like it's written. Okay, so follow those steps. Find the standard deviation. need to make sure you clear out the old numbers in that list. So you have to delete those guys. Delete button is above stat. Question? Biggest number minus the smallest number. It's not actually in there, so you can use what's in there to find it, but it's not a number given to you. Okay, so when you use your calculator to find the standard deviation, what do you get?
5.66.
Yep. You should have 5.66. So one more time, it's this snaily guy here. Okay. Just in case you want to know, it's not really a snail. It's a lowercase Greek s, but it is, looks like a snail to me. Upside down. Or tape. Oh, it does look like a tape measure. 5.66. Okay. Now, what's the range? Range is 21. Okay. Why? Or let's go this. How did you get 21? 23 minus 2, right? 23 is the biggest, minus 2, which is the smallest. Again, if you want, like if you had a really big set of numbers, if you down arrow, this is what your gibberish comes up to, right? It looks like this. But if you go down, there's the biggest, there's the smallest. So you can use your calculator to do it. You just have to do the subtraction. 23 minus 2. Okay. Now, last thing I want to talk about. This is on your homework. The last thing I want to talk about is changing okay, we'll just say this. Changing the measures. Okay? So let's say your quiz, your last test. Let's say the mean was 75. The median was 70. The mode was 72.5. The range was 20, and the standard deviation was 5. Yep. Gotcha. Okay, so let's say that was true on your last test. And let's say that I looked at that and I was like, there was a couple crappy questions on that test that I could have explained better. And instead of making you retake it, I said, let me just add 10 points to everybody's score. Okay, now here's my question. We do not have any way to go back and regenerate what those numbers were because I'm not giving them to you. What would happen to the mean? How much would it go up? It would go up 10 because everybody got 10 points added to that. Okay, so the question that we're talking about is what would happen if we added 10? Okay, so I'm going to put them right up here. The mean would go up 10. It would be 85. What would happen to the median? It would be 80 You guys, because I just want you to think about, imagine this, like if it's this, if you could have the things, the numbers like physically in my hands, all I did is take your numbers and shift everybody up 10. So the middle number isn't going to change because everybody's getting 10. So whoever had a 70 there, now they have a 80. So the median is going to go up. It's going to go up 10. Okay? What's going to happen to the mode? It's going to be 82.5. It's going to go up 10. What's going to happen to the range? Nothing. Why?
Oh, should I explain that?
Yes, please.
Well, you add 10 to everything, so nothing like stays behind, so they're all equal.
Exactly. Nobody's staying behind, right? The maximum gets 10 added to him, and the minimum gets 10 added to him. There's still the maximum minus the minimum is still going to be 20. Nobody gets left behind. I like that. Nobody gets left behind.
What is that symbol? Is that like a small symbol?
That is standard deviation. It's my snaily tape measure. So this stays the same. Okay? Standard deviation measures how spread apart everybody is. Okay? What's going to happen to him? He's going to stay the same because I gave everybody 10 points. I'm not changing how spread apart they are. I'm just giving everybody 10 points. Okay? So sometimes you can figure out what's going to happen without having all of the numbers to do it. So let's say, this would never in real life happen, but just saying. Oh no, we'll go this way. Let's say you like McDonald's. Okay. And their average price, so this is going to be McDonald's prices. Let's say their average price is $4.50. Their median price is $3.25. I'm making this up. I have no idea. I haven't eaten at McDonald's in a long time. Their mode price is $1.99. We're just going to put $1.50 to make life easier. Okay. Their range of prices is $10, and their standard deviation is 2. It's always good when you can make things up. So what if, here's our question. What would happen if McDonald's doubles all their prices? Okay, they're going to double all their prices. What's going to happen to the mean? What would it be? It's going to be times 2, right? It's going to be doubled because we're doubling every price. That means the mean is going to be doubled. It's 9 actually. How about the median? What will happen to that? It's doubled because you take your, whatever your value, your quarter pounder with cheese, $3.25. If you double that, you're doubling the median. Okay. How about the mode? Doubled. Okay. How about the range? Nope. It's actually doubled. Okay. Let me show you why. Let's say before, so you don't have to write this down, but let me show you. Let's say their most expensive was $1 and their least expensive, and their most expensive was 11. That gives us a range of 10. Okay. What happens if I double this guy? 2. 11 would turn into what? 22. What's the range? This range is 10. This range is 20. Okay. What's going to happen to the standard deviation, do you think? Also, it's going to double. Because you're spreading things out. You've got low numbers doubled. You're giving it a much larger spread. From 1 to 11 versus 2 to 22, you're spreading things out more. So your variation is going to be more. Okay. So different things happen when we multiply or we add. Okay. When we multiply, everybody changes. When we add, range and standard deviations stay the same. Okay, so here's what we're gonna do. We're gonna do homework. I'm gonna tell you what ones to do first. So I'm gonna put them in order because you have to do a couple standard deviations. So you want to get those done first because you need the calculator for those. So I would like you to do okay. There's 5 questions. These 3. Yep, just a second. These 3 you need your calculator for. Okay, so get on it because you got to do standard deviation for those 3 things. Gold Star Club, you're just 16, 19, 21, 22. Okay, you need a calculator for those 2. Yep.
Well, when you actually said that, I was feeling